Today's journey takes us to a world extremely close to the Sun. It's Mercury. Did you know that Mercury is the smallest planet in the solar system and the fastest to orbit the Sun? Despite its small size, it's full of mysterious secrets and fascinating landscapes, from massive craters to extreme temperatures that make it one of the most extreme planets. In this video, we will uncover: why is Mercury so incredibly fast? How does it endure scorching temperatures of up to 430 degrees Celsius (800 degrees Fahrenheit) during the day, while dropping to minus 180 degrees Celsius minus 290 degrees Fahrenheit at night? Could there really be ice on Mercury, despite its proximity to the Sun? Get ready to uncover the secrets of Mercury in this thrilling cosmic adventure. Don't forget to like, subscribe, and turn on the notification bell for more space explorations. What amazes you the most about Mercury? Let us know in the comments. Mercury's surface temperatures are both extremely hot and cold. Because the planet is so close to the Sun, day temperatures can reach highs of 800 degrees Fahrenheit (430 degrees Celsius). Without an atmosphere to retain that heat at night, temperatures can dip as low as minus 290 degrees Fahrenheit minus 180 degrees Celsius. Despite its proximity to the Sun, Mercury is not the hottest planet in our solar system. That title belongs to nearby Venus, thanks to its dense atmosphere. But Mercury is the fastest planet, zipping around the Sun every 88 Earth days. Mercury is appropriately named for the swiftest of the ancient Roman gods. Potential for life. Mercury's environment is not conducive to life as we know it. The temperatures and solar radiation that characterize this planet are most likely too extreme for organisms to adapt to. Size and distance. With a radius of 1,516 miles (2,440 kilometers), Mercury is a little more than one-third the width of Earth. If Earth were the size of a nickel, Mercury would be about as big as a blueberry. From an average distance of 36 million miles (58 million kilometers), Mercury is 0.4 astronomical units away from the Sun. 1 astronomical unit, abbreviated as AU, is the distance from the Sun to Earth. From this distance, it takes sunlight 3.2 minutes to travel from the Sun to Mercury. Mercury's highly eccentric, egg-shaped orbit takes the planet as close as 29 million miles, 47 million kilometers, and as far as 43 million miles, 70 million kilometers, from the Sun. It speeds around the Sun every 88 days, traveling through space at nearly 29 miles, 47 kilometers, per second, faster than any other planet. Mercury spins slowly on its axis and completes one rotation every 59 Earth days. But when Mercury is moving fastest in its elliptical orbit around the Sun, and it is closest to the Sun, each rotation is not accompanied by sunrise and sunset like it is on most other planets. The morning sun appears to rise briefly, set, and rise again from some parts of the planet's surface. The same thing happens in reverse at sunset for other parts of the surface. One Mercury solar day, one full day-night cycle, equals 176 Earth days, just over 2 years on Mercury. Mercury's axis of rotation is tilted just 2 degrees with respect to the plane of its orbit around the Sun. That means it spins nearly perfectly upright and so does not experience seasons as many other planets do. Moons. Mercury doesn't have moons. Rings. Mercury doesn't have rings. Formation. Mercury formed about 4.5 billion years ago when gravity pulled swirling gas and dust together to form this small planet nearest the Sun. Like its fellow terrestrial planets, Mercury has a central core, a rocky mantle, and a solid crust. Structure. Mercury is the second densest planet, after Earth. It has a large metallic core with a radius of about 1,289 miles, 2,074 kilometers, about 85% of the planet's radius. There is evidence that it is partly molten or liquid. Mercury's outer shell, comparable to Earth's outer shell, called the mantle and crust, is only about 400 kilometers, 250 miles, thick.
Right kind of solar viewing equipment, telescopes or binoculars with the appropriate filters, you can see it from the ground, but the best way to see it is from space. We've got data coming from the Solar Dynamics Observatory, which is going to show this roughly 7-hour transit uninterrupted.
Why are transits so important to astronomers?
Well, transits have been used for hundreds of years to show us distances. Like a ruler, we can figure out how far away planets and the sun are. We've also been able to figure out sizes, or even the fact that Venus has an atmosphere using transits. But transits are also important because they're how we figure out if there are planets around other stars outside of our own solar system.
How does NASA watch the sun?
Well, the sun is constantly putting out huge amounts of energy and material. It's producing its own space weather that affects us here on Earth, affects our astronauts in space, and impacts and moves throughout the entire solar system. And this transit is really important because it allows us to fine-tune our observations of the sun to see even better detail by using the transit itself to fine-tune and focus the telescope to give us the best possible data to show us the sun in all its glorious detail.
So NASA is using the transit method to study planets beyond our solar system. What do we expect to learn from future missions doing this?
Well, we've already found thousands of planets around other stars, and we've got future missions like the Transiting Exoplanet Survey Satellite, or TESS, which is going to look at the closest, brightest stars to give us a whole set of potential candidates that we can then point even more powerful telescopes like the James Webb Space Telescope at to see the very atmospheres of these stars, look for the fingerprints of life itself, and hopefully get a better understanding of life on other planets and ultimately life on our own planet.
Surface. Mercury's surface resembles that of Earth's moon, scarred by many impact craters resulting from collisions with meteoroids and comets. Craters and features on Mercury are named after famous deceased artists, musicians, or authors, including children's author Dr. Seuss and dance pioneer Alvin Ailey. Very large impact basins, including Caloris, 960 miles or 1,550 kilometers in diameter, and Rachmaninoff, 190 miles, or 306 kilometers in diameter, were created by asteroid impacts on the planet's surface early in the solar system's history. While there are large areas of smooth terrain, there are also cliffs, some hundreds of miles long and soaring up to a mile high. They rose as the planet's interior cooled and contracted over the billions of years since Mercury formed. Most of Mercury's surface would appear grayish-brown to the human eye. The bright streaks are called crater rays. They are formed when an asteroid or comet strikes the surface. The tremendous amount of energy that is released in such an impact digs a big hole in the ground, and also crushes a huge amount of rock under the point of impact. Some of this crushed material is thrown far from the crater and then falls to the surface, forming the rays. Fine particles of crushed rock are more reflective than large pieces, so the rays look brighter. The space environment, dust impacts and solar wind particles, causes the rays to darken with time. Temperatures on Mercury are extreme. During the day, temperatures on the surface can reach 800 degrees Fahrenheit, 430 degrees Celsius. Because the planet has no atmosphere to retain that heat, nighttime temperatures on the surface can drop to minus 290 degrees Fahrenheit, minus 180 degrees Celsius. Mercury may have water ice at its north and south poles inside deep craters, but only in regions in permanent shadows. In those shadows, it could be cold enough to preserve water ice despite the high temperatures on sunlit parts of the planet. Atmosphere. Instead of an atmosphere, Mercury possesses a thin exosphere made up of atoms blasted off the surface by the solar wind and striking meteoroids. Mercury's exosphere is composed mostly of oxygen, sodium, hydrogen, helium, and potassium. Magnetosphere. Mercury's magnetic field is offset relative to the planet's equator. Though Mercury's magnetic field at the surface has just 1% the strength of Earth's, it interacts with the magnetic field of the solar wind to sometimes create intense magnetic tornadoes that funnel the fast, hot solar wind plasma down to the surface of the planet. When the ions strike the surface, they knock off neutrally charged atoms and send them on a loop high into the sky. And so, we reach the end of our journey with Mercury, the smallest planet in the solar system and the closest to the Sun. Despite its small size, it holds incredible secrets about planetary formation, extreme temperatures, and unique geological changes. If you enjoyed this space journey, don't forget to support us by liking, subscribing, and turning on the notification bell to stay updated on the wonders of the universe. Which planet would you like to explore next? Let us know in the comments. See you in a new video with another cosmic adventure from planets and depths.